Steve, we kind of left off where we were talking about the Juno spacecraft. Okay, you're there. You've gone into polar orbit around Jupiter. What are you going to do? What can the spacecraft teach us about Jupiter?
So what we're going to do, we want to understand the inside of Jupiter. We want to let Jupiter teach us about itself. And the problem is you can't go physically down inside to get that. So we have to look at the information that comes out of Jupiter. Well, if you look at what comes out, what's the first thing? That would be the gravity field. Gravity comes from the entire planet. So by measuring the gravitational field of Jupiter, we're learning about the deep interior. We can do that really simply. The spacecraft falls around the planet in orbit. What we do is measure how fast that spacecraft is falling, and for example, Jupiter's rotating every 10 hours. If there's a dense core in the middle, then the shape of that interior will be different than if there's no dense core.
Wait a minute, you say it's rotating, I'm sorry to interrupt, but it's rotating once every 10 hours. Are you saying its orbit, its day is a 10-hour day?
Yes, Jupiter's day is 10 hours. Jupiter is 300 times the mass of the Earth, and it's spinning more than twice as fast. So if you look at the exterior of the planet, you look at a good photograph of Jupiter, you can actually see that it's stretched out at the equator. It's not a sphere. Right? Interior of Jupiter is doing the same thing, but we don't know exactly what that shape is, and it depends on the mass distribution. So if we measure the gravitational field, that will tell us about whether there really is a dense core down in the middle like we think, and how big it is, because its shape will be rotationally distorted. That's not the only way we get information from the gravity, but that's one of the pieces of information.
Now, how is Juno going to be doing this? I mean, what kind of suites of instruments does it have that it's going to be using?
Okay, so we measure how fast it's falling using to get the gravity. That's just the radio transmitter. Radio comes from the Earth. You know, we transmit a signal to Jupiter, transmit it back. The difference in frequency tells you about the speed. We measure the magnetic field, because that comes from deep inside the planet. It's generated in this enormous ocean of liquid metallic hydrogen. Really cool stuff. You know, you take hydrogen gas. If you had it here on the Earth, it would float up in the sky. You know, fill a balloon with it. On Jupiter, it's squeezed so much, the pressure's so high, the temperature, the conditions are so extreme that you not only do you squeeze it down to make a liquid, you squeeze the electrons right off the atoms. It conducts electricity. That stuff swirling around makes the magnetic field.